This is a very hard question, very long, very interesting. Let's go through it. So the first thing I would advise you to do when you do an NMR question, especially if it's a long one, is to label the peaks. So we would say peak A, B, C, D, and E. And for everything that is very difficult, I think the best thing is to start by the easiest side, which in this case I would say is to analyze the area. So from the area, here is 3, and therefore methyl, 2, and so on and so forth. Here the area of 4 is quite tricky, but if you check the ppm, an area of 4, 5, with a ppm around 7, it's always benzene, always. In this case, that is substituted for hydrogens. We don't know which groups are here, and we don't even know where the positions of these question marks are. I put them there, but maybe they are next to each other. After the area, I would analyze the splitting. Really helpful. So, triplets, that means that peak A is next to a CH2. Quartet, peak B next to methyl. Doublet, CH. For the benzene ring, do not analyze the splitting pattern. We cannot interpret it. It is beyond the A-level specification. And then for peak E, it's a triplet, so next to a CH2. Now here you can stop a second, and we can actually see that, you see how A is next to a CH2? There are two CH2s, B and C. So pause the video and think, which one out of B and C is this CH2 going to be? It's going to be B, because B is also next to a CH3, whereas C is not. C is next to E, and E, therefore, next to C. And this is, again, is very, very helpful. It will make your life easier later on. Okay, so then it comes the type of proton, which probably is the hardest part to analyze, I think. So, pick A is force here. So it's a HC bonded to a carbon, a normal carbon with hydrogens. Pick B force here. So it could be NH, OH, and these three. It's not OH or NH because it's not a singlet. It's not this HC bonded to N because there's no nitrogen in this molecule. So it's got to be either this or this. Because we don't know, we write both. For C, remember at the beginning of the question it says that the peak of 3.7 really should be at 2.7. Therefore, pick C falls in this range, and again, could be that or that. Pick D and then pick E falls here. It's an aldehyde, for sure. So once you've got here, is when you have to put all the information we've got so far together. So for example, for C, we knew that the area was 1, so that works just fine because it's an aldehyde, area 1, and it's a triplet, so it was next to a CH2, and we knew that this CH2 was C. So that means that C is next to a carbon double bond oxygen. Therefore, now we know the type of proton for C, and C is going to be area 2, so it's a CH2 bonded to a CH from the aldehyde. That's proton C, that's proton E. Now A and B, A we knew it was a CH3 bonded to a CH2, and we knew A was here, and B is this one. And then therefore for B, it's got to be this type of proton, because there's only one oxygen in the molecule. Remember the molecular formula? So it cannot be this again, it's got to be that one. And therefore it's going to be CH3, CH2, bonded to a disubstituted benzene ring. So we have nearly done it. We have the first fragment, which is included in here. This benzene ring is disubstituted, so we know it will be bonded to something else. And then we have the second fragment, which would be this one, and we have to put them together. So that's what we would get. That's proton A, proton B, benzene ring. That's proton C and proton E. But we haven't finished quite yet. Because remember, they said that the carbon NMR spectrum contains 8 peaks. So if the substitution on the benzene ring happens on carbon 1 and 4 of the ring, then we will get 1 peak, 2 peak, 3. And then this carbon and this one is symmetrical, so are these two. So they only give you 1 peak each. So overall you get 8 peaks. However, if you had a 1-3 disubstitution or 1-2, then you will get 10 peaks. And therefore, the right isomer is this one. So as you can see, we have to use all the information given in the question. And that's it. I hope it makes sense. And bye for now.